Hello, so it's 2 o'clock. We start with the presentations from the hackathon. I follow the Meet Echo order, so that might be a different order than you see on Data Tracker. If you submit slides, they might appear. Just it's an ongoing process. The Meet Echo people will help us. We have a lot of presentations, so we want to limit the presentation to 2 minutes and 30 seconds. And we will use a timer also to give some idea how far you are in the presentation. The first presenters are, well, they're on the screen. The Seaboy. Please go ahead. You can use the.
Yep. Hello. I don't know. Hello. As part of the hackathon, I planned on doing some implementation work with Pact Cibor. I found many interesting people to talk to. Did completely different things, but before breakfast, I implemented a minimal version that works. So that's what I did for the hackathon. If you want to play around with it more, see me around or at the Cibor meeting. Thanks.
Thank you. Up next is next one is TLS client puzzles, and after that is VCon. So VCon can already also come over. So the TLS client puzzles, and next is the VCon. Yeah, no problem, no problem. That's why I should pre-announce.
Yeah, so I worked a bit on TLS client puzzles. Oh, it's not progressing. Yeah, we built used time this weekend to build a proof of concept implementation in Chromium. Had a lot of interesting discussions with people about potential alternative solutions. So going forward, I'm looking towards having more of those discussions. So if anyone wants to have those discussions and is interested in TLS and TLS DDoS protection, please come talk. And I have figured out I need to do a lot more benchmarking and also benchmarking in different ways. So that's going to be fun. If you want to discuss stuff with me, I'll be here today, tomorrow, and Tuesday still. Come talk.
Thank you. We're doing very well. So next up, VCon, and after that. Yeah. Okay. VCon and then Rocka S. Is that a remote presentation, maybe? Going once, going twice. Yeah. Impressive. You're lucky. Charles is not very strict. Your timer didn't start yet.
Almost timed out. Right.
Here's the mic. Yeah, it is what it is.
So we worked on VCon, which is there we go. VCon is the conversational data container used for data exchange in like contact centers and things like that. And so we focused on a couple concepts here, all related to how VCons can refer to other VCons, because you have you may want to do in a redaction, or you want to modify a VCon that's signed, or you may want to be grouping a bunch of sub conversations into a larger concept of a conversation. And so the goal was to look at these concepts and how they would be implemented, for appending some additional content for VCon, and as well as grouping of the VCon concept. Oops. There we go. So people who joined us, some new participants and some old. So what did we do? We added additional Python support for 3.1.1. Found some bugs in the documentation and testing and things like that. We've got our first Rust implementation of econ. Woo! And we actually dug in a little further into the concept of a redacted vcon, was another kind of concept where one vcon references another, and found some interesting things there. And we actually probably did more kind of design work or conversational conversations around resolving some issues or cases where there was multiple approaches to solve some problems. And so I think we spent more time talking than actual coding, but we still got some really good stuff done. We discovered there is actually useful to have the root vcon referenced in a redacted vcon as well, because you can't always traverse the tree. We found explored a couple different ways of doing the appended concept of a vcon, and I think we in our discussion found a good way or a better way to solve that problem. And you can see the open source here. These available as Python packages, but of course, stuff we did this weekend here is not yet available. That'll be a month or two down the road.
Thank you. Next, the RockRS. And after RockRS is the low latency crypto. There we go. Yeah. Okay, maybe it's easier to do.
Okay, thank you. Thank you. So I would like to present about the RockRS. So RockRS is the authenticated encryption algorithm based on sponge construction with 256-bit key and generate 256-bit message authentication tag. And it can provide 256-bit security against key recovery in classical setting and 128-bit security in quantum setting. And I have an internet draft here, and also there are several open source implementations in GitHub, which also include the result of Hackathon last year. And this year, I did implement RockRS for mobile phones and did the performance evaluation using OpenSSL as a base and use OpenSSL speed command to measure the throughput. And this is the result. And I verified that the performance of RockRS is the fastest among the easiest or AES, and on Apple A16 and A18 Pro. And on A18 Pro, RockRS achieved more than 100 gigabps. And I believe this is very important, especially considering in next generation of the mobile communication, the target peak data rate is 100 gigabits per second. So the RockRS could be suitable encryption algorithm for the next generation of the mobile communications. And so if you're interested in high throughput encryption algorithm, please contact me or find me. I will be here for the entire week, and this is the acknowledgement. And thank you very much.
Oh, so up next, the low latency crypto, and after that, the antagonist. There you go. Come over.
Thank you. Good afternoon, everyone. I'm Yumi Sakemi from GMO Cybersecurity by ERI Japan. Today, I will talk about our hackathon activities. Okay. First, I explain about overview of low latency crypto Arayon. Arayon is a secure and low latency cryptographic permutation and based on AES instructions. For more details, please refer the IETF 117 hackathon slides and internet draft. And through our previous activities, we found that Arayon is faster than current cryptography, such as AES-256 DCM and SHA-256 under the following conditions. In this hackathon, we try two tasks in this hackathon. One is implementation of Arayon by Rust, and the other is evaluation of Arayon on a mobile device. As a result, we have successfully implemented Arayon by Rust, and we plan to publish the code as OSS soon. And next, we have successfully evaluated the performance on Pixel 7. For your reference, I include the experimental results on Pixel 7. So I hope it's useful for it's helpful for you. Next steps is short insight. We need to optimize the Rust code because the current code is reference code. And about the evaluation on Pixel 7, unfortunately, we did not confirm the expected effects of Arayon, so we need to investigate more. And especially, we are looking for effective applications on Arayon, so your comments are welcome. That's all of my presentation. Thank you for your attention.
Thank you. So up next, the antagonist, and after that, interface to the network function.
Hi, everyone. So this is Antagonist. Antagonist is substantially a label store for network anomaly detection. So we realized there was the need to add this component to the network anomaly detection system and architecture. And this tries to solve two problems mainly. One is the creation of a label data set for network anomaly detection, which is a big issue in the industry overall. And the other one is the support for human in the loop. And by trying to solve this problem, we identified that there is a possibility to define a life cycle for the network anomaly detection improvement over time with three different stages. And we realized that it was mandatory to find a way to standardize the API for this label store in order to make sure that the objectives are achieved. And so the two drafts that this project is trying to validate are trying to standardize basically that API somehow. So there was some pre-work done in other IETF iterations, IETF Hackathon iterations in the past. What we added on top of that, these 2 days, is substantially the validation of these by integrating it with our implementation of the RFC 9418 as a rule-based anomaly detector. We identified some gaps, and we refined completely the way the API of the label store is structured. So we extended the young models in the two drafts. And in terms of next steps, we're going to refactor the whole application because this needs more work and integrate with the Swisscom lab. This is just a quick picture of the models that we currently have. And as I thank the whole team, I want to invite people who are interested in more details to come talk to me or attend, even better, attend the NMOP working group. There's one slot on Tuesday, 9:30 a.m., and one slot on the afternoon, 6 p.m. On the first one, we'll speak about the drafts, and the second one, we'll speak about the hackathon details. Thank you.
Thank you. Okay. Up next is the interface to the network, in network. After that is careful resume tests. So for the careful resume test, did you provide a new version? Okay, I have to. All right, one moment. Okay. Okay, I find it. Final. Yeah. Okay, I have to scroll a bit. Sorry for the intermittent. And also, if you have a double presentation in one slide desk, can you notify me? So we give you 5 minutes. Okay, sorry. Please go ahead. Oh. Oh, no. Sorry. This one. Please go ahead.
Yeah, hello, nice to meet you all. I'm Joseph An, from a PhD candidate from the Songyungan University in Korea, and I'm going to talk about the interface to in-network function project. And the champion of this project is the Professor Jeon Jung in Songyungan University. So this is the poster of our project. So we're going to have a presentation on the Hack Demo Happy Hour tomorrow. And the goal of the Hackathon project is to demonstrate the feasibility of intent translation in I2INSF and framework. And especially we focus on the intent translation and policy provisioning, and especially about the creation of the YAML intent and its deliberation to SDVs. And we also gonna have the introduce of our I2INF project on the OPSA working group on this ITF. And this is the structure of our I2INF. And it starts from the SDB user, and the user give the intent to the cloud controller. And inside there, intent translator translate the intent and give it to the SDB through the wireless network. And the SDB, after they receive the policy, then it give the data to the cloud analyzer, and it save the data in the database. This is the flow diagram of intent translator, and a specific detail about the intent translator. It first extract the attributes from the high-level JSON intent sent by the STB user, and after that, it translates the JSON intent into a YAML intent based on the rules, and finally, it translates it transmits the YAML intent into the STB controller. So this is what we learned. We learned implementate the intent translator and demonstration of the intent-based networking. So this is the demonstration of our project. And this is the demonstration of the intent translator. You can see the specific code on the GitHub, and the specific video clip we uploaded on the YouTube together. The next step, we are gonna focus on the developing the intent translator, and on the next ITF, we are gonna make the develop the intent translator based on the AI-based scheme, and also we will design the young data model for the main I2INF interface. And this is our hackathon team. The professor from the Songyungan University and Aju University and Dongin University and the Daegu University, and for the researcher who came from the Esri and TTA, and especially from the Sokendai person also joined to our hackathon team. Yeah, thank you very much.
Thank you. So, there we go. I have to find you. Okay, so after the Okay, now I'm a little bit. Okay, next one after this one is PQ in X509. And then we go to your presentation, latest version. All right, this one. There you go.
Hi, everyone. We were all up at the hackathon at the congestion control table, and we were running some tests with careful resume. Now, what is careful resume? Right, and also buckle up because we have about 20 slides to do in 2.5 minutes. Yeah. So careful resume is a method that a transport can use in order to increase congestion window of the congestion window of a connection in the startup of that connection. So this relies on the server understanding a little bit of the path characteristics to the client that is talking to it. The whole point behind this is to get you up to speed much faster than slow start. Right, so at a hackathon, we just ran tests. We have careful resume currently implemented on top of Quick, specifically Pico Quick and Quiche. And the point was to just try to do some H3 testing with the major browsers, which we've done. And this is the first ever time that we've used careful resume to do like a real web page. So we had a fairly large web page that contained multiple objects. And to make things more fun, we also had a delay emulation box, which you can see here in the picture. So there we go. Pretend this is a video. Pause for effect. Right, so when the server uses careful resume, everything loads faster. We save about 2 seconds, which is roughly 3 RTTs. And whereas that was Quiche using Safari, for a change, now you can see the same thing with Pico Quick and Chromium. Careful resume, again, performs much better. That was most of the slides.
Thanks. So just a video with very few frames per second. I ran Linux with PicoQuick as a server. Here we can see Chrome. I just showed the end screen. So we have a benefit of roughly 2 seconds. And the same is true if we use Firefox. So the overall loading times are a little bit higher, which is probably due to the handshake, but we still can see a gain of roughly 2 seconds by using careful resume. And that's it. Thank you.
Thank you very much. Big hands for your improvisation. Thank you. And your flexibility. Okay, so next is this one. Oh, right. Yeah, so PQ, thank you. And after that is the validate configure subscription Yang push.
Okay, thank you. So I'm here to talk about the PQC and X509 project. This is actually our 7th hackathon. So this group, yeah, we basically worked for interop testing for the PQC. Then there's been new algorithms, probably most of you know that NIST has just come out with in August. So of course, our testing has more urgency against it. The other thing is we gain experience and give feedback to a bunch of the working groups that are working on drafts. So there's a bunch of drafts listed there that we help give feedback to. So what got done, this is the important part of what was done. So a few things, actually quite a few, I have 3 slides of these. So the crypto providers, so people that submit artifacts for testing. So now they've been supporting MLChem, MLDSA, and SLHDSA. So those are the new algorithms. So we're starting to get some testing of those things. So that's great to see. Also, the automated GitHub action. So that was added back in July. So that's been updated to a new version 4 file that gets triggered that has a lot of the new algorithms. And so we keep that up to date. Also, we have a new validator. So QuantCrypt is I think a Rust library And so that obviously gives diversity of algorithm implementation. So that's actually being worked on as an automated part of the automated GitHub Actions as well. So now when people submit artifacts, they'll be automatically tested against OQS, Bouncy Castle, and QuantCrypt. So that's exciting. A couple things that we found. So there's some testing done with CMS Chem artifacts. And I know I'm almost out of time, but one thing that was important we found, so the private key format for ML Chem can actually be in more than one format. So there's this 32-byte seed. There's also a longer format. There's possibly even a longer format. So we found with some interop testing, some people were using one format, some people were using the other format. The other thing is inside the structure, there's an octet string wrapping, and that can help with whether it's one format or the other. And some implementations had that, and some implementations did not. So basically, the takeaway from is that we need to make sure that the drafts that are talking about these private key formats have clear guidance on the format. So I think this is a good output of this hackathon to know that this actually we had some interop issues with that, and we can work now to resolve that. Yeah, so and there was also some work being done on doing automation for the CMS artifacts as well. I know I'm running out of time, and so a couple other drafts that got updated were composite chem. There was a good composite signatures, the new version that was just landed 2 weeks ago. There was successful interop of that, added testing of hash MLDSA as well, updated the OI tables, and one interesting thing, an ASN1 querying tool for RFC structures and PyASN1 modules. So if you want information about that, you can come talk to us as well. And I'm just going to go through this quickly. So we have OID mapping tables for interoperability testing. This is a sample of our compatibility matrix. This is hot off the press. You see, nothing is actually saying it passes everything. That's because OQS, so Open Quantum Safe, does not yet support any of the new crypto algorithms. So that's why it's only partially there. And yeah, summary, we've had lots of people do this. We're going to continue. Next meeting is Tuesday, December 3rd. So that's remote. And then, yeah, we keep doing this. We have a hackathon page, and come join us. Sorry, try to get that all in quick. Thanks.
Thank you. Thank you. And thank you for your continued contribution. You're already a group for many IETF hackathons and contributing. So happy to see that. And next one is indeed validate configured. After that is the L4S, and I understand that's a double presentation. Yep, excellent. All right. There we go. And if you happen to submit a revision, make it clear before I load the slides so I can look for the latest revision of your slide desk.
Hi everyone. We were validating young push publisher implementations for configure subscription. And our test, our plan was actually to track the progress of the vendor implementations, especially in regards with the roadmap of the MVPs we have, right? So we want to reach the basic requirements milestone. We got the different softwares listed here, so 3 publishers and 2 receivers, and we also provided the UDP notif dissector, as we will see later. All the test results are in the test repository, so it contains packet captures, message samples, and also the automated test sequences. Then we have here all the document references that are relevant for these implementations, and we see on the right-hand side how do they contribute to the young push to Kafka integration, message broker integration. So what they contribute exactly. So then here we have subscription change notification for Cisco iOS XR, and the push updates for periodic and on change subscription, and the same for Huawei VRP. Then for VRP, we have also the extension of Young Library for augmented by, which is also like a contribution to the message broker integration that is needed. Then we have the third vendor is 6Wind with also the subscription chain notification and the push notification. Then here I said the UDP notif, especially with the segmentation enhancement optional. And we have, 3 publisher and 2 receivers supporting this, and a Wireshark dissector that is available as well. So then here, this is the status to reach the first milestone. So we're still progressing, still some stuff to fulfill. And there are also some features already for the second and third milestones. So that's the team we had. Some are remote and the other locally that contributed to the success. Thanks a lot.
Thank you. Thank you. Okay, so for now the double presentation L4S, and after that, okay, after that I will see the application DNS CBOR update. Yep.
Thank you. So I'll give the first part of the presentation here. So this is the 6th time that we have run an L4S interop at the IETF Hackathon. And I'm Greg White from Cable Labs. Move on to the next slide. So the hackathon plan this time, as in previous hackathons, is to work on congestion control coexistence with L4S and also congestion control performance, as well as the TCP accurate ECN, and in addition, quick ACK ECN as well. So if you're not familiar with L4S, it's a new congestion control architecture that allows the network to provide fine-grained congestion feedback to applications, to the congestion controller in the application. We had 5 implementations of congestion control attending this time. Netflix Simple Rate Control, NVIDIA's GeForce Now WebRTC implementation, Chrome Quick Prog, UDP Prog, which is bundled into iPerf2 now, and then Linux TCP Prog. The network that we were using for testing these implementations is a GPON network emulator that supports L4S, as well as a Wi-Fi AP with L4S support, and then lastly a Linux bottleneck with the dual pi squared QDisc. In terms of congestion feedback from the receiver side, 3 implementations being tested this time. One is Google Chrome, the libWebRTC implementation there, as well as UDP Prog and Linux TCP Prog. As in previous hackathons, the L4S interop doesn't end at the end of the day today. We run through the rest of the week as well. So after we clear out of this room, at the end of the day, we'll be in the Liffey meeting room, a couple of doors down for the rest of the week. Relevant RFCs are listed. In terms of what got done so far, so Netflix declared successful testing of their simple rate controller, both with local servers on the other side of the bottleneck, as well as remote servers across the internet, and did testing with a comparison of performance with TCP Prog in a shared bottleneck, so the 2 competing against each other in a fair manner. Google Chrome Quick, some very initial testing of that implementation. So successfully sent ECT1 packets from the browser and saw ACK ECN returned from the server. UDP Prog with iPerf2, work has been underway to add a rate limitation mode, which allows the iPerf2 to be used to model, say, an application limited stream rather than a fully greedy stream. And then the last one, NVIDIA GeForce Now WebRTC congestion controller with the Google Chrome libWebRTC client. That'll be the second half of the presentation here. I'll hand it over in a second. In terms of team members, a number of folks who have been attending these previous interops at the hackathon, and some new folks as well, and a number of first-timers who've their first hackathon for IETF. So with that, I'll hand it over to Harold.
Thank you. So L4S is fun because you can't test it without support of the network. So we who do endpoint only systems have a hard time. It's good to have a hackathon. So, you know what L4S is, I guess. Support requires a reporting format in WebRTC with ECM bits. That's RFC 888, for instance, and L4S aware congestion control. So previously, this was untested. We didn't know if it would work. But Google has implemented experimental support for generating feedback messages. And NVIDIA has implemented reacting to those feedback messages. So you will notice that no end has both parts. But neither has been tested with a real and L4S capable network. That's what we did here. Hackathon setup, server in London, NVIDIA folks offsite, I think they're in the US. L4S routers from Nokia, monitoring by Cable Labs. We had gigabit from London to the L4S router, and then the L4S router had a bottleneck of 20 megabits. Bam! And if you saw us playing games, it was to generate load on the network, of course. Results, we found that L4S is extremely sensitive to flight size. If you send a whole video frame as fast as possible over a gigabit network, and it hits a bottleneck, L4S will say, oh, that's too much packets. Let's mark the last one. So that's an unjustified backoff. So the solution is to adapt flight size, slow down the last packets a little bit. Might also fix that L4S node, but that's not the right thing. But we definitely discovered that exactly where we need to do further experimentation. And our code worked. Hooray!
Thank you. All right. Up next is the. I do see an antagonist -00, but it's the same slice set, I guess. I didn't hear any complaints. So again, sorry, application DNS CBOR update. Thank you, Martin. And after that, it will be digital map for ISIS and OSPF. Martin.
So yeah, I'm Martin, and I updated mostly my DNS plus CBOR implementation, which is a CBOR-based format for DNS messages. The plan was to update the implementation to the most current draft version, because over the last year, quite a lot of things were happening in the draft. If you're interested, you can read through all this later on, I guess. I managed to do roughly half of it. You see that in the middle there is an incomplete list of stuff. That was mostly because just before lunch today I realized, oh, I didn't run every test every time, and so I realized only then that my implementation was broken. So I used the time before lunch to fix everything again, and then started implementing the other stuff. And by now, after I handed in the slides to the beginning of the presentations, I actually managed also to implement the SRV records. So this list isn't that current anymore. So what we've learned, first of all, there were some definitions that were a little bit wrong, that you could read a little bit wrong, and including myself, I read it a little bit wrong. And then some stuff broke if you didn't implement it correctly. So I will amend the draft to provide this information. And from the thing that happened before lunch, even if you want to save time and only run a selection of your tests, rather test everything, you will save a lot of time. So team members was just me, and yeah, actually I need more implementation in different languages than just the implementations I have. So currently there's only my Python implementation C4 DNS and an implementation in Riot. And yeah, if you want to have a look at the draft, please do, and provide some implementations. Thank you.
Thank you. Sorry. All right. Yeah. What's the name? Is the same? Okay, then I should be good. Okay. Thanks. Right. Okay, here we are. Here's the presentation. Yep. Yeah.
Okay, thank you. So, hello everyone. So today I'm going to talk about the digital map. And this has been a couple of times in the hackathon. This is, we're trying to see, to say what has been done last time and what has been new for this time. Okay, so for a quick overview for digital maps, so we're trying to do basically a topology mapping. So we do the mapping from downstream from the network to, and then we see how we can represent this using RFC 8345. And we did this last year for RSIS, and this year, yeah. So this is for this, what has been done this time. So we are doing this for, we're running discovery for more operator labs. We are adding more scenarios like the simulation emulation example, and we are adding more like how to link the topology to other parts of the, or the domains in the network, which in this example, we are looking at net configuration example, like configuration domain. So this is a quick overview over the labs that we used. So 3 labs. For this example that I'm going to share, it's basically the simulation example or emulation example. And this is basically more details here. So we have we call it what if scenario. And here we are trying to look at topology change basically after and before configuration change. So we're looking to see how we can use the RFC 8345 and its augmentations to represent the change in the topology. So we have 3 states before the change, state 2 is the change, state 3 is after the change. And you can see down there that, you know, affecting one layer, we can see the topology change on another layer, layer 2 and layer 3 in this example. And this is more details on every step. So, and this is more like how we can see the links before the change, how many links. This is more like a specific area, for example, and then there are a couple of links here. So we are trying to see how we get the reference to be able to look at the configuration from a specific topology node. So this is more details on how to do this. And this is before the change, and this is after the change. So you can see the links are down there, and then we see the response. Basically, from the topology, we see how to go to configuration and how to know what's the reason, basically. This is more in details how we are doing this. So we are doing some proposal on how to do this in the DB. What data we need to store on the reference to link the topology to configuration. So the summary, what I've said, basically what we have achieved. So more on the takeaway on this part is we are able to, or basically it's the first candidate option that we can do connect the topology to configuration part. So what we are doing next time, we are adding more layers, BGP Service 6, and we're going to add more operator labs next time. So thank you.
Thank you. All right. Next one is we have this one. Experiments with MTL mode. Okay, thanks, excellent. And after that, there's the BGP LS extension.
All right, thank you. For this hackathon, we worked with Internet Labs to do some experiments with MTL mode and DNS resolvers. What is MTL mode? MTL mode is a conservative way to do post-quantum secure signatures. It's a mode of operation for signatures that lets us sign an evolving message series. So things like zones, OCSP files, where things continue to come in and you're adding them to your signature series. MTL mode is a way to sign and verify those. So we worked on the draft or implementing the draft that is the MTL mode DNSSEC draft. There's several repositories here you can see that explain what we did or what code we used. Just a note, there is some IP around MTL mode, so read the declarations if you're interested in information about that. All right, so at IETF 121, this is our third IETF working on MTL mode. We actually implemented the DNSSEC draft. We were able to get an SD serving the authoritative zone with the EDNS flag option for retry, and we were able to use Unbound to provide validation of those signatures and retry when it needed to get the full signature on the series. The results were successful, so we were able to configure the recursive resolver, is able to query the authoritative server and verify the signatures and get all the pieces it needed to fully provide the DNSSEC validation on the zone with the scheme that is post-quantum safe. So next steps, if you want to learn more, there's a PQ DNSSEC side meeting on Thursday from 10 to 11 here, where we'll talk more about some of the things we learned from this. There's a couple other talks there too, but if you want to learn more, come to the side meeting, and thank you for your time.
Thanks a lot. Thanks. Okay. After the BGP LS extension presentation, there will be the Kira Hackathon results.
Hi, everyone. We worked on the implementations of BGP LS extensions for SRv6 service function chaining. This is our hackathon plan. Our primary goal is to implement BGP LS extensions for some GoBGP implementations. And to enable a controller centralized for network service segments. And yeah, we worked for that. And this is the concept of SRv6 SFC architecture. And we worked on the middle of the figure. This is the BGP LS extensions for SRv6 network controller. That is our hackathon. BGP service segment. We implemented two types of TLVs. One is service chaining TLV, and the other is opaque metadata TLVs. This is our implementations. One is GoBGP, that is a BGP daemon written in Go language, and Wireshark, that is a very famous network protocol analyzer, and we added some dissector for BGP LS extensions. And Polar PCE is OSS path computation element, and this is implemented by our team. And this is the figure of this hackathon. And there are two Go BGPs, and we implemented some SRv6 NLRI, and we capture the packets between them, and Wireshark dissect the BGP-LS packets. This is our result, and we implemented SCTLV, OMTLV, and SRv6 NLRI, and API and dissector is partially completed. Here is our code and team members. So if you interested or would like to join us, please feel free to contact us. Thank you.
Okay, Kira, and then after Kira presentation, there will be the topology graphical display. Is it -00? Is there also another version? Well, we'll figure out. Okay.
Yeah, hi. My name is Roland. I'm presenting the results of the Kira at Hackathon. Oh. Okay. Yeah, what is Kira? By the way, it's a scalable zero-touch routing protocol that we implemented in Rust. There's a related draft. It is ID-based routing and uses path IDs for forwarding, which is a little bit similar to label switching. It's all IPv6 based, and we test it in ContainerNet, so several containers running and interconnected by some virtual connections. The problem is now if you're trying to figure out when things go wrong, to debug the forwarding plane consistency. So when the ping doesn't get through, who's the culprit? So the approach I came up with yesterday basically is to write a Python script to automatically get the route information in a hop-by-hop manner. And yeah, what worked was basically a direct connection, which is not very interesting for a routing protocol, but nevertheless, I got two nodes talking to each other. I got the ContainerNet installation running on a new version of Ubuntu, performed some automated tests, and got the idea for that Python script. And I'm currently not finished yet, but maybe this afternoon. So yeah, team members, not so many. Unfortunately, the team at home had no time to join. We plan some refactoring of the codes aligned with the latest draft. We're also working on an eBPF-based implementation for the forwarding tier, but that's ongoing work. There's a general project page in case you're interested in Kira. And there will also be a side meeting or bar bruff. So if you're interested, please join on Wednesday after the plenary. Thanks.
Thank you, Roland. Right, here we are. The graphical display, and after that, the format analysis for tested TLS. Yeah, you can use the page right.
Hi, everyone. This is a T topology for graphical display. Well, the challenge for this presentation is that it's very hard for me to go over time. It's so simple. Let's start. So we developed a tool that can basically graphicalize the T topology JSON file. Why we want to do that? It's because T topology model is quite complex, and we use this graphical tool is to help people to understand its key aspects of the T topology. And this tool currently can support 4 fundamental RFC and the draft, is all of which are topology related. And the gap we found, well, the tool is far from being perfect. And the major challenge that I can think of on top of my head is that it requires improvement of the young compiler to make it more be able to compile generic YAM models. And we definitely hope that the tool will gather some interest from the community and so that we can collaborate on improve the tool. And the future work that we can think of for this toolkit is that we like to have a contribute to building a comprehensive young simulation framework that can help us to really put the young models into action, like to interact with the young models. Like we can generate ResConf, NetConf interfaces automatically derived from young models, and we can even generate some young push notifications from the young models as well. So if you're interested, please contact us. This slide is in the already in the website, and you can find us if you're interested. We can talk offline. Thank you very much for your attention.
Thank you very much. Thank you very much. Right. Yep. And after the experiments with, oh no, sorry, after the formal analysis of TLS, attested TLS, it's Yang-2 RDF. Yep. There you go.
Cool, thanks a lot. The best response that I get from RAT's mailing list is, these are very good questions. We will get back to you soon. And that soon never happens. So it was a good opportunity to talk to the RATS guys. And what we did was how we can add attestation in different channel protocols. And TLS is one of those examples for confidential computing specifically. Oops. Okay, so the plan basically was to work on attested TLS to see how we can specify them. There are 3 ways in which it can be added to the the secure channel protocols. The first one is that we do attestation first, and then we add it to the TLS protocol, pre-handshake attestation on the left. And then the second one is that we do the TLS handshake first, and then export these materials to the remote attestation part. The third one is that we mix them together such that both happen in parallel or combined together. That's the strongest binding we can have between the two. So that's the intra-handshake attestation. So the IDs that were involved were one on attested CSR and the other one on attested TLS or TLS attest. And as I said, the goal was to work on the specifications for confidential computing. And I want to, oops, oh, sorry, it's a bit of a lag. Okay, I want to thank all of them for the discussions that we did. So in doing the specifications for the tested TLS and the tested CSR. And what we learned from this exercise was that we got some better understanding of the channel bindings, as I showed, like TLS happening first and then the remote attestation, or the other way around, or the mixing of the two, how the channel bindings happen in each of the cases. We have analyzed that, and we analyzed the trade-offs, or we actually analysis basically here means we did only the discussions, so it's only theoretical, nothing in practice. We will work on those. So both drafts, we had discussions around what are the trade-offs, in what kind of use cases one will be better over the other, and so on. And one optimization that was proposed is to analyze whether certificate verify can be removed for a specific use case in which we have intra-handshake attestation. And thanks to the participants, so we have 2 proposed new properties, which means that we have not analyzed them yet. And we would like to analyze them for further analysis, which are, if a connection is established, client and server agree on attestation, binding from attestation to the TLS, and the other way around, which is that if remote attestation appraisal is done successfully, client and server agree on all the TLS connection parameters. Okay, so to wrap up, we have 2 side meetings in which we will discuss all of these things about attested TLS, one going into the basics, all the 3 options, and then we will see what are the kind of the trade-offs between them, and pre-handshake analysis like Intel's RATLS protocol that we have analyzed, and the post-handshake where we don't have any draft yet, which is Scone's attestation protocol. We will analyze that. And finally, there are pointers to some of the works that we have. So feel free to go through them and reach out to us if you are interested. Thanks a lot.
Yeah, okay. Okay, there you go.
Hi, hello everybody. And as one of the few natives in the room, welcome to Ireland. Yang to RDF. I have to go this way. Yes, so what is RDF? RDF is a standard by W3C. It is quite old. It is the definition of a triple. It's a way of representing a graph information. There's obviously the whole semantic web stack here. We're not going to go into it, but essentially trying to represent knowledge in a graph format in an open standard. Why do we need that? Well, in order for us to potentially use all of the information people like you have been developing over the years in Yang, we need to be able to represent it somehow in RDF in order to use it in knowledge graph. This is something we have been working on. It is using a kind of a clever approach by using some open source tools that already exist in order to convert from, or use an open source parser, convert that to RDF. We do a bit of clever stuff with Sparkle, and we output some RDF at the other side. Here are some results. For a specific device, a Huawei device, we were able to create, parse the Yang models and create that number of triples, quite a lot. You can see here an example, a simple query shows the representation of that module in a graph format. You can see how quickly that can grow. This is the same module, but with all of the listening containers. This is the same module with all the list containers and leafs. The query that you can see down here is Sparkle. It's very simple. This is where we are. Full support for all the language, but maybe not full support, fully parsed or augmented with deterministic IRIs. That's maybe for the next time. If you have any questions, interest, please have a look at our draft. This is why we're doing it. Thank you.
Thank you. I forgot to mention the next presentation, so here it comes. Please bear with me. All right. Okay. I'm now a little bit lost. So I think we haven't had protocols for quantum key distribution. Next. Yeah, excellent. And then resumable uploads from the HTTP. Oh, yeah, yeah. Yeah.
Thanks. Hi. Okay. Yeah, we forgot our first slide, but I'll start with the first thing we did. We built or trying to build some protocols for quantum key distribution networks, and there are still some protocols missing which are not standardized. And one thing we try to do is like a bulk key sync for, with an in-memory distributed database. And it sounds really fancy, but in practice, it's relatively easy because we have some special requirements which make this relatively special and not as hard as it sounds. So because we do a quantum key distribution network, we have some requirements. For example, we want to guarantee unconditional secure communication. And we have for this database exactly 2 nodes. And for example, stuff like data loss is not a big problem as long as it happens on both nodes simultaneously. So yeah, weird for a database, but in our case, that's true. And also inconsistencies are not a problem in specific constellations. So also something that normal databases do differently for obvious reasons. But for us, yeah, it makes things different. And even a reboot of one of the database nodes should trigger a complete delete of everything, which is also some different stuff. And so on and so forth. For example, also data comes in only through one route and goes out another. So you don't have like multiple users connecting to it. The only thing we have to make sure is that if data is read on one side, it's also available on the other side. So that's nearly the only thing we need. And if you look at the scheme, it's like we have the 2 nodes and the data is coming from the bottom and we just have to make sure that it's connected and synchronized. And so we thought about some basic buffer structure where there's an input buffer and it's synchronized in a shared output buffer. And that's the only thing that we really care about. Don't have the time to really explain it, but yeah, it should work in theory and we built a basic demo. And with the data we got there, we can do a handshake. And this is, for the handshake to make a secure communication with the data we got from our database. And on this last slide, you can see it's just a basic two-way auth handshake where you can tell your parameters you have for your cipher and use the data you got from the database to make a secure handshake. And if you want to keep up with us, here's our link. Thank you. Thanks.
Okay. Resumable uploads, and then we have the IETF. Oh, wait a minute. Well, what's called? Is it acronym? EA. Probably you can pronounce it as a word. EAPRAD. Over there. Yeah. Excellent.
Hi, everybody. We worked on resumable uploads over HTTP. And resumable uploads are basically a way to make normal file transfers resumable, meaning if they get interrupted for any reason, they can be resumed without retransmitting the data that has been transmitted before. Overall, we like to make uploads with this possible, but also more resilient, especially if you have large file transfer over a slow or unstable connection, which happens pretty quickly with mobile networks, for example. We are working on a draft for 2 years roughly now, and it's shaping up pretty well. The draft is getting pretty stable. We are nearly feature complete, so it was a good time for this hackathon to work on a few implementations that we already had. Overall, we wanted to upgrade existing implementations to the latest draft and then also test interoperability between them. So we set out to do that. We have quite a few implementations. For example, the URL session API in iOS and macOS already supports this. So most modern Apple devices already ship support for this. We also have a JavaScript client that runs in Node.js and browsers with now even better types, thanks to TypeScript. We have a small example client in Go, just if you want to read a small program, not a large one. And on the server side, we have fully featured servers in Go and .NET, whatever fits your deployment, a bit more experimental server in Swift Neo, and a small example in Go as well. All of them are updated to the latest draft, which is really great. There's also a GitHub link down here if you want to learn more about these implementations, including some documentation on them. So yeah, that worked great. And then we tested interoperability, and you can see with all of those nice green check marks, they all work perfectly together. We didn't come around testing the Swift Neo example because then suddenly lunch appeared and then we didn't have the priority anymore. But yeah, we'll definitely get back to that later. So yeah, that's it. Thanks a lot to Goya and to Matthew who worked on this with me. There's the draft again. We'll discuss it tomorrow in the HTTP Biz session. So if you're interested in that, feel free to check it out. Thank you.
Thank you very much. Yeah, and after this presentation is the SDF at work. Yep.
Yeah. All right, thank you. Okay, hi, I'm Karri Huhtanen from Radiator Software. Our group was this kind of combination of persons working in the RATEX group and also in the EMU group. So we had this kind of combination of implementation work, discussing of the trust, making kind of trial implementations, and also kind of checking out this interoperability and how these are really implemented in the actual devices. There are the trust there, implementation work, and I will go into the testing side next there. Okay, yeah. So this is the kind of setup we have there in the table 2. You are welcome to come closer there and check out the test there, and we can kind of discuss all of these technologies and details also there. The results of this testing, so we had 3 different APs there, and we tried to test the radius over TLS RADSEC. Does it really work properly in the implementations done by the vendors? And this is the kind of results there. Maybe one important thing about this is that only one of them did TLS version 1.3 with radius over TLS, and none of them did the server certificate identity validation properly there. So maybe nothing new about it, but this was now tested. In other test, we did also this kind of radius roaming test with open roaming, successful test with 5 different open roaming IDPs, as well as with SIM authentication with dynamic discovery for the 3GPP network.org realm. What we learned that the support is not yet there for TLS1 version 1.3, and the certificate installation, handling, validation, and configuration needs improvements in all of those tested implementations. Comments about the trust will be presented in the respective working groups. There is FIDO in the EMU group, and the other trusts are in the RATEX group there. All right. Thanks.
So the SDF presentation, who's taking care of that? Remote maybe? Okay, SDF at work, NIPC, that's excellent. Maybe I pronounced it incorrectly, apologies for that. And then after that we have the Scrappy CBOR presentation.
All right, sorry about the name change. We actually started with 1 project and we ended up with 2. Oh, all right. So we worked on two problems. First of all, using SDF in networking environments. SDF describes interactions of things. And then we kind of looked at how we could use that in real-world networking environments for, in SCIM, for example, for device onboarding, as well as in NIPSI, which is an application gateway for non-IP protocols. So we looked at how SDF could interoperate with those. Then we also looked at converting models between ecosystems. So specifically looked at Matter for this. So the latter, Matter to SDF, a converter was written by Nicholas Mayer, and others in the team here tried it out and basically verified that it could be used by them with their SDF models. And it was Dockerized as well, so it's easy to use. An ongoing project there is to document the actual demo setup that showed a physical Matter device interact with a non-Matter device using SDF. So it was lightweight M2M and a Matter device. And then the second project is SDF with SCIM and NIPSI. So we basically reviewed all the different deployment models that we could have here, gateways, middleware applications, and so forth. And we ended up mapping NIPSI into SDF by basically including NIPSI quality in SDF. So you could basically define a mapping between an SDF property and what that property actually looked like on the wire in the protocol. And then we kind of looked at it the other way around as well. So how could a NIPSI gateway learn about a thing by basically registering an SDF model to it, so giving it an SDF model. And then we also created or defined a manifest that could be leveraged in SCIM, MUD, manufacturer usage description, or NIPSI to map an SDF model to a thing. The team members, quite a few of which a few here and a few remote. There were also first-timers, two first-timers, and we will continue the discussion in the ASDF working group face-to-face meeting on Thursday. Thank you very much.
Thank you. All right, the O2 version, thanks. We'll go from bottom up. All right, yeah, maybe it has to.
Yeah, that's almost my whole 2.5 minutes there. Yeah, so mission here was to we've made decent progress in the interim on the architecture. So now we've got an API for Skit. And it was a funny mishmash of JSON and CBOR. I tried implementing it clean. It was hellish. So we figured, let's actually just make it all CBOR. Follow the mission, nice, clean, single thing to deal with, single encoding, all good. So this is working on the Skit Scrappy draft and really trying to make CBOR and COSI central to it, which is part of the mission of our wider group, but also make it usable by professional programmers. So what we got done, got a fresh implementation of 9290. This is CBOR problem objects. Thanks to Christian Amsus for helping me make that decision. That worked out pretty well. We've got a fresh implementation of Scrappy in Python from nothing. Live end-to-end registration and retrieval of receipts. For folks who don't know, Scrappy is there to help you very easily put things onto transparency logs and get them off and verify them again. And we can do this in effectively a one-liner. And we've made lots of improvements to the Scrappy spec in line with that that base mission that we had. Now, I say we did all those things. Actually, most of those things turned out to be done by ChatGPT because we spent first hour desperately trying to work out how to write CDDL and CBOR and actually get the tooling working. So eventually I gave up and I asked ChatGPT to do it for me. And what do you know? It actually did. It knows what to do. It built me those things. It built me sort of simple Python class to do it. And it even gave me an example of how to call that. So you might notice here, it wasn't quite exactly perfect. It didn't quite have all the tags. And for some reason, it's really allergic to negative numbers in tags. But apart from that, it was all good. So I implemented that and it all worked. And we even got an update to the architecture for free, because why not? After hammering on cbor.me and it just saying validation failed at us, ChatGPT to the rescue, it's all good. So what did we learn from that? Well, working with Cozy and CBOR, it's nice when it works. We love it. I like the mission, great hackathon, but it is not as easy as it should be. Now, this clearly isn't a core problem with the specs, because if ChatGPT can do it, the spec is parsable and reasonably complete. So it is worth doing this. It is worth doing it for Scrappy, but we need better tooling. And we've had a couple of discussions during the hackathon about, improving the tooling and developer accessibility for this thing. We were supposed to have a second version of these slides. So another thing we did do, which is on the web somewhere, was Nobuo-san was looking at applying Yang vulnerability principles to Skit and Scrappy to make sure that the real world can actually use this thing. And that came out positive too. So we've kind of learned Scrappy's good, fit for purpose, just needs to be more accessible for developers. So, okay.
Thank you, thank you. Up next is the DNS Hackathon project. That's 2 or 3 presentations even combined. At least 2. And after that, after the DNS, is the NTP working group hackathon project.
So, and I will forget these over here. As usual, the DNS work is a bunch of different things, so this will be a bit of a potpourri. Philip worked on, what did Philip work on? Yes, Philip was working on the Untitled Labs Rust library, essentially, which is, to all of us, something we're all waiting very much for. Stefan and Schumann, bits and pieces of different stuff. DNS ossification, which is a problem we all have, etc. Thomas worked on DNSSEC, DNS KSK rollovers. Andre worked on a prototype implementation of the new DLEG work, not done in any way, but we need something to play with. And the thing that I can actually say the most about is my own project. For some reason, there is more text here. I have no idea why. So this is sort of a multi-year effort. We've been doing this both during hackathons and elsewhere for a number of years, and it's sort of starts with multi-signer. We get sidetracked into generalized notifications, which becomes automatic delegation synchronization with dynamic updates, and now we're sort of circling back to multi-signer again, that we have lots of infrastructure in place for actually addressing that problem. So now we are doing the first steps of the distributed multi-signer work. And that's it. Thank you.
Thank you, Johan.
Yes.
So yeah, hi for the NTP. And after that is the RPKI RTR update.
All right, thanks. I'm Marcus Donsoye. And so we put together, this presentation is on 2 different projects that have been done under the NTP working group. So first, we've been making NTP version 5, which is the next version of the networking time protocol. We're doing testing there on various implementations of the current draft. And we've also been doing interoperability testing of rough time. And rough time is a new time synchronization standard that aims to make it possible to actually prove malfeasance of time servers. And in the case of rough time, there's about 4 server implementations out there and about 6 client implementations. And we wanted to check if they actually work together. So what was done was NTP v5 actually tested using NTP version 5 over long distances between different networks and used a couple of the experiences from there to actually clean up existing implementations. And I've been told it was successful and they actually managed to synchronize time. And when it comes to rough time, we built this interoperability testing framework, which we call Plummet. And that basically tested all the implementations against each other, and we generated this interoperability matrix from it. So as you can see, sort of interoperability is sketchy, and I think most of the failures here are due to different draft versions being used by the different implementations. And so we learned a lot of things. We found and fixed a number of bugs. We today actually identified a serious security issue in the rough time draft. We realized we had regressions in the drafts, issues with draft language and readability. And we also had a team member work on a new rough time server implementation. To wrap up, team members, me, and I forgot David Van Hoek, who's also been working here on site, Ruben Niefeld, who wrote the new rough time server implementation, and then we had Sarah Grant with us remotely. Yeah, that's it from us. Cheers.
Thank you very much. Let's see if I... After this presentation, implement find relationships. Okay.
Okay, so this is about updates to the RPKI RTR protocol. So RPKI is a PKI for making cryptographic statements about internet number resources. It's mostly used by resource holders to say which ASNs can originate announcements for their addresses. Network operators then run relying party software that fetches that data from the repositories, and then routers fetch that data from the relying party software via the RPKI RTR protocol to work into the route sort of classification process. So the draft on this page is the 3rd iteration of the RPKI RTR protocol. The main thing is a new object type called ASPA, which allows for a form of path validation to happen on the router, but there are various other fixes and improvements in that document as well. So the work for the hackathon was about our reference demonstration implementation. So we updated that for the new ASPA PDU, asynchronous server implementation, and a few other things. Unfortunately, the other implementers weren't able to be here, but we have a set of automated integration tests for those projects. So once they make their updates, we'll be able to do interop fairly easily. Thank you.
Thank you. Right. Yes, after this one, after the implement find relationship, is the SCHC interoperability.
So I will introduce the find dependency solution with reverse dependency list in the IETF YARN library. And the motivation for the find dependency solution is to provide a lightweight solution for utilizing the YARN models and its references without missing dependency. For the YARN application, there could be different one, but in this one, we're focusing on the YARN Kafka architecture. And for the previous hackathons, we have implemented the open source code for the augmented by list for the YARN library augmented by draft. And in this one, we aim to incorporate with the Huawei new test release that supports the following two drafts: YARN notification, versioning, and the YARN library augmented byte. And we have also extended the libyarn push to also pass the YARN notification versioning message content. So what got done? We have delivered a test program to pass the YARN push subscription updated message, which is sent from the Huawei new test release, and we are able to read the subscribed modules according to the subscription filter, and we are able to pass the module version for the subscribed module. And we also deliver a test program to generate get YARN lib RPC call according to the subscribe module and pass from the YARN lib response the reverse dependency list, which is in the red box. And what we have learned, so for the test of extension of the test of the draft netconf YARN notification versioning, we learned that the module version can help the YARN push subscriber to learn about the module changes from the subscription notification. And we also incorporate and validate the YARN Huawei test release with the libyarn push. We have wrapped test code in the Docker image and publish on GitHub. And for future work, we will improve the library to also pass data store filters that contains multiple filters. And we also aim to deliver an application to real-time read and pass the message, YARN push message. So this is the web hub. Thanks for your time.
All right. Let's see, where are we? Thank you. Thank you for your patience. So after this presentation, there will be the Thread Hackathon report. It takes longer and longer for me to find the right presentation. We have a list of 40-ish presentations.
Thank you. Yeah, so hi everyone, my name is Alejandro Fernandez, and we worked on SHIC interoperability. So lately we have seen the development of more SHIC implementations. So there was, of course, OpenSHIC. Now there has been recently open sourced full SDK, which is a C implementation for STM32 systems. And recently there has been also MicroSHIC and CSHIC. So in fact, they all have like different rule types. They implement, of course, the core compression mechanism. But yeah, they are not necessarily, yeah, of course, they're interoperable. Like rule format and output format is not the same. So we specifically worked on OpenShick this weekend. Now master branch is up to date. We have merged some examples for our online Chic course. You can have more information in this link. Of course, there's still work in progress, like testing. Again, please test your code. And we tested the CSHIC and MicroShic implementations, which are like they have very clean code. Actually, it's very nice. So overall, Chic implementations are maturing. We are in a very nice time frame for Chic implementations in general. Right now, we have more work to do on testing and documentation. We've decided to keep a simple rule format for at least for the Python implementations. On the C implementations, we are using a CBOR sequence. And yeah, so also the implementations are missing some core conf for rule management, but that's also in progress. So yeah, right now we're working in LabChic. You can access the website through this QR code. We have some examples, demo, documentation, everything is there. So yeah, thanks so much.
So next up is a threads hackathon summary or report, and then we have, I think we're close to the end. The last one I've here on my list is the eBPF SRv6. If one of your presentation is missing, please come over to Charles here in the front. So then we missed an upload. Please walk over to Charles and we make sure you're in the next slot. Okay, thank you. Up to you.
This is a really amazing turnout. This looks like the most people I've seen at a hackathon, and most people are actually working, not just checking their emails, so that's good. We had a fun time today and yesterday hacking on some Thread devices. Very quick summary. For people who don't know, Thread is a wireless IPv6 network. You can think of it a bit like Wi-Fi, but lower speed and much lower power consumption. Devices can run for a year or two on a single battery. This time we had 10 people participating, 1 remote, 9 on site. We also had generous support from some of the silicon vendors who sent us some development boards and hardware to use, which was pretty cool. This is some of the hardware we've been playing with, building a mesh of IPv6 nodes that are communicating wirelessly. Here's our happy crowd of hackers. And one last slide on a few of the things we did. We had fun trying out the different developer boards, the different development tools that they provided for them. We took some wireless Thread nodes and put them on tables here to see what the range was in this crowded environment. And the answer is, this is a tough environment for 2.4 gigahertz. Not a big surprise there. We did a bunch of work on the simulator. Had some good conversations with university professors who are actually doing hands-on open thread programming assignments for their students, which sounds like a lot of fun. So if anybody else is interested in that, talk to us and we can help you get that set up. And we'll be doing this again next time in Bangkok.
Thank you. So we have eBPF, and then I'll go back to your presentation. Apologies for missing that one. Okay, up to you.
Thank you. So usually you trace packets with Wireshark, like what are the receive packets and the send packets, but there's a tool called Packet Where Are You, or PWRU. It's a open source project from Cilium, and it can trace the packets inside the Linux kernel, so you can see what are the functions called when the packets passing through your systems. We find 3 subtasks, like Yari implemented how you can filter empty packets. These are like netlink packets or not TCP or UDP packets, not really meaningful for networking. Tamás Lévai from Budapest University implemented user-friendly names for network namespaces, and I started to implement segment routing v6 support. It's work in progress, so you can find our changes in the fork, and we plan to send a pull request to the original project. So basically, that's my case when here's an output of the tool. As you can see, there are some filtered functions as the segment routing 6 packet passing through the Linux system. And by default, the tool can't really decode the TCP and UDP ports because it's somehow miscalculated the offset of the layer 4 header. We fixed that, but we can't really show right now the segment routing, the segment IDs. And here's what Tamás did is, like, if we have some meaningful names for the network namespaces, like for example, in Kubernetes, you can have the pod names and stuff like that. We can, on a new column, we can show you those names, not just the IDs, what you can find next to this column called netns. And that's what we did basically. Thank you.
Next up, the RPP.
Okay, a lot of great work today. I think this is the last one. We've been working on what we call the RESTful provisioning protocol, and it's a proposed standard for provisioning domain names in domain name registries using a RESTful API. It's kind of an alternative for the already existing extensible provisioning protocol, EPP. EPP is basically a stateful XML-based protocol over TCP, and we're proposing a, yeah, as I said, a RESTful API. So using HTTP with the REST style, but try to use as much as possible from the existing EPP standards, and instead of XML, go with a JSON data format, including schema validation. So for this hackathon, we didn't do any actual coding, but we did do a lot of work, a lot of talking about requirements. For instance, we talked about, okay, what kind of requirements should the protocol have, or requirements for object representations. And we also did some modeling of object representations in JSON just to see how would something from XML look in JSON. What we actually got done was we updated our requirements document. For instance, we looked at authentication. So how could we support modern authentication mechanisms to support the current use cases, but also possibly future use cases. Looked at EPP compatibility. So how much from EPP should we support in RPP, and also extensibility. So how can we make it easy for implementers to extend the core RPP protocol? We also made a prototype data model for a representation for a domain name object. And what's also very cool, we worked on a type spec API design, which allows, if you have a type spec code, you can compile it into an open API definition, which you can then use to generate client and server stubs. What we learned, okay, how much time we have? Not much time. So we can learn from what EPP did and maybe not take over everything from our EPP, but only the things that are actually used and not carry over any legacy parts. See if we can build in EPP extensions into the core of RPP instead of using them as extensions, and a lot of discussions about how to model context into RPP. And most importantly, Wednesday we have a BAF. You're all invited to join us. It's going to be a very interesting discussion. Thank you very much. Thanks. Thank you. These are my slides. Okay. I think we have all the presentations. If not, raise your hand. No? So this is my slides for closing. So first I'd like to thank all the speakers to keep within the time frame. I know it's tough within 2.5 minutes, and you did an excellent job. Thank you. Thank you very much. If you would like, some people did send a revision in the meantime. If you would like to see a revision in the data tracker, in the IETF proceedings, please submit a new version before the end of this week, because I don't know what happens after this week. Maybe it moves directly into the IETF proceedings. Things are closed. I don't know, actually. So just to be safe, send your new revision before the end of the week of your presentation. Furthermore, closing. So there are a number of things to mention. Tomorrow we have the Hack Demo Happy Hour. It's between 7 and 8 on the ground floor. Please present your project to the IETF-wide community. So consider to write up, to put down your name, and you can give a presentation or you present your results in a poster session to the other people, and you have some interesting discussions. Furthermore, there will be a room where you can work through the week. That is the code lounge. That's on this slide, of course. Some more information. And you can also use on the wiki, you can find the schedule link or the schedule for, mentioning that your team is in that room for that time slot. Did I forget something before we close down? Charles? No, I think we're complete. Then I would like to thank our sponsors for this hackathon weekend. This Ericsson, the gold sponsor, Meta, the silver sponsor, and ICANN, the bronze sponsor. So many thanks to them. They make this, provide for the food in the room and all the nice things we had this weekend. Thank you. See you around this week. And if you find any things that need some improvement, send some feedback to the hackathon chairs. We're more than happy for any feedback. Thank you.